Good evening, everyone. Thanks for joining, and it's really a great pleasure for us to explain about this lighting production earthing systems. And if you take this lighting production system, we always explain this as the most underrated natural disaster. So, if you take the natural disaster, this lightning alone is causing more than 2,500 deaths in India alone per year. But we are not providing proper importance to this protection against lightning, as the deaths are happening not in a single stretch. So the deaths are happening from the January to December. So, but we are not providing proper importance to the protection of this lightning protection system. So we always consider this lightning protection as the most underrated natural disaster. In this lightning protection, the risk assessment is the most um, the topic which is unaware to most of the people. So we take this opportunity to explain about this importance of risk assessment calculations in the designing of lightning protection system. So before going into this topic, I'm just explaining about a small brief about our company. So I'm coming from CIKIT Electricals and Technologies. We were started in 2018, but we have an experience of more than 20 years in this field of lighting production and earthing. And our main focus is providing solution rather than promoting our products. So our approach is we have to provide proper solution to this problem related to this lightning and earthing. We also provide customized solution to this lighting production and earthing, and we won't provide generalized solution. For example, if you take oil and natural gas industries, we cannot go for the same 62305 standard. We have to go for a separate standard called OAST-GDN, which was published by Oil Industry Safety Directorate, which is very specific to this oil industry. So we are providing customized solution based on the site conditions, and we are providing end-to-end solutions starting from the site survey, risk assessment calculations, designing, material supply, installation, and periodical maintenance, which includes auditing of the existing lighting production system as well. So we are providing end-to-end solutions for both lighting production as well as this earthing. So as I mentioned, these are the different standards which we refer for this lighting production and earthing. So for oil industry, we are referring OAST GDM. So similar to that, if you go for high-rise buildings, we will be referring in addition to 62305, we have to refer NBC also. So which explains about this risk associated with this due to this lighting protection on high-rise building which are above 60 meters. So for these are some of the standards which we refer for this lighting protection systems. So lightning. So, so lightning is a natural phenomenon which is the discharge of charges from the cloud. So due so, whether my voice is audible, whether my voice is clear, shall I proceed in the same? Is it audible now? Shall I continue? Okay, fine. So lightning. So lightning is nothing but the discharge of charges from cloud to the ground. So during this thunderstorm conditions, charges will get accumulated on the usually positive charges will get accumulated on the top portion of the cloud, and negative charges will accumulate on the bottom portion of the cloud. During thunderstorm conditions, because of this, opposite charges will get induced on all the objects that are connected to the ground. For example, if you take one building, this building will also send this positive trigger. If you take one person standing on there, the person will be sending a positive trigger. So if there are any other objects that are standing in the ground, that objects also will send the positive trigger. But the path will be closed through this positive charges, which will reach the negative charges first. So in this case, the positive charges are sent by this ground as well as the tree. But the negative positive charges from the tree will reach this negative charges first. So the path will be closed through this tree. But it doesn't mean that only the tree is sending a positive charge. All the objects that are connected to the ground will be sending a positive charge. But the path will be closed only through the charges which reach the negative charges first. And in most of the cases, the charges coming from the cloud will be negative nature. But in some occasions, the charges coming from the cloud can also be positive, but that is a rare incident. But it can also happen. So if the charges coming from the cloud is positive, then all the charges sent from the ground will be negative. So opposite charges will get induced on the ground and it will be sent from the ground. So we always consider this cloud to ground as the lightning, but apart from that, there are two more types of that. So the intra-cloud lightning is nothing but the discharge happening within the same cloud. So if you take the cloud, positive charges will be there on the top and negative charges will be there on the bottom. So the discharge happens within the same cloud is called as intra-cloud lightning. In another case, so if the lightning happens from one cloud to another cloud, so this type, if the lightning happens from one cloud to another cloud, then it is called as cloud to cloud lightning or inter-cloud lightning. So the number of lightning happening within the same cloud and from one cloud to another cloud is much higher than cloud to ground. But we always consider this cloud to ground alone because that is the lightning which causes damage to these human beings and physical damages to the structures and electronic equipment failure. So we are considering only the cloud to ground, but apart from this, there are two more types of lightning is also there. So before addressing this problem, we have to find the source of the problem. So if you take this lightning, so the lightning can cause damages in two ways. One is direct effects, another one is indirect effects. So lightning directly striking on a building and causing this damages will be coming under this direct effects of light strikes. At the same time, if the lightning can happen at some other place and the surges can travel through the ground or transmission line and it can cause the damage in some other place. So here the strike point will be different and the damage will be different. So this will be coming under indirect effects of strikes. So if you take the damage sources, there are four different sources of damages. So the first source is lightning striking directly on the building. So apart from that, if lightning strikes near the building, at that time, because of the discharge, the ground potential will be much higher. So because of the increase in ground potential, cattles and other electronic equipments may get damaged because of the increase in ground potential. And third point is the lightning striking on this power line. So during the childhood days and during thunderstorm conditions, I was not supposed to watch the TV because they will turn off the TV and at the same time they will unplug the TV from the power supply. So at that time I wondered, what is the reason for unplugging this TV? I am sitting inside the house, the TV is also inside the house, and what will be, how the damage will be caused. But after entering into this lightning field, I found the answer. So the answer is, if lightning strikes on any power line, the surges can travel through the power line, and we are taking power supply from this power line only. So the surges can travel through the power line and enter into our house. So if these equipments are plugged, then the surges will travel through this power line and affect this electronic equipments. So only knowingly or unknowingly, we protected those electronic equipments from these surges. Apart from that, lightning striking near the power line will also cause the damages. So these are the four different sources that causes the damages. And the damages can be physical structures, damage to the physical structures, or the most important thing is injury to human beings, loss of life and damage to the physical structures and electronic equipment failures. So these are the three commonly damages that can be faced due to this lightning. So these are some of the incidents that were recorded due to this lightning. So the first one is the fire accident that happened in oil storage area. So in this we can observe that apart from the physical damage, the lightning can also result in fire and explosion. So whenever we are taking protection measures, we have to consider fire protection measures as well a part of this lightning protection system. And second one is the structural damage. And third one is also a damage caused by the fire. And fourth one is due to the ground potential rise. So in this almost 30 cattle died and there was no mark of lightning on not even a single cattle. So because of the ground potential rise, all the 30 cattle died. So we are meeting so many people and many people are asking the same question. So the lightning is very dangerous. We have to go for the protection, but the lightning protection is mandatory for all the structures. So I am having one house. The house itself is around 10 meters in height and it is around 2500 square meters. So this is a very small house. Whether I have to go for lightning protection system for the small house. This is the most commonly asked question by so many people. And second one is How can we select the level of protection? So if you take this lightning protection system, there are 4 levels. So level 1 will be highly sensitive equipments like explosive storage and for hospitals where the efficiency will be 99%. But level 4 will be for normal buildings and residential areas where the efficiency will be around 84%. So how can I select this level of protection? Whether is there any thumb rules, or shall I go with the for explosive storage, I can go for level 1. For college and other buildings, I can go for level 2 and 3. For normal residential building, I can go for level 4. Is there, whether is it advisable to go like that? So, and third one is if I'm having a residential building. So, for example, if you take one builder, they might be doing one project in Chennai, and the same design they might be using it in Hyderabad or Mumbai areas. So, for this Chennai area, if they have that risk assessment calculation and if they have come up with lightning protection system design, whether the same lightning protection system is applicable for this building in Mumbai or Odisha in some other areas. So these are the commonly asked questions related to this lightning protection design, risk assessment and the level of protection. So in this upcoming slides, we will be going through the solution for these questions. So lightning strikes. So if you take this lightning strikes in India, so number of lightning strikes is much higher in this belt. So if you take Odisha, Chhattisgarh, Uttar Pradesh. So in this area, if you take the number of lightning strikes is much higher. After that, it will be in Maharashtra regions. So the number of lightning strikes is much higher in this area, and the number of deaths due to lightning will also be higher, and the damages due to lightning will also be higher in this area. In some areas, if the lightning itself is much lower, then the risk due to lightning also will be much lower. So whenever we are going for this protection of lightning protection, then the first parameter that has to be considered is the location of the particular site. So if the building is in more prone areas, then the risk due to lightning will also be much higher. Then the designing has to be done accordingly. So the design which I did for this Uttar Pradesh area or Odisha area, that area is more prone to lightning. So if you take the remaining areas, like if you take the Rajasthan area and all, the number of lightning strikes is much lower. So if I am doing a design for Rajasthan area, here the number of risk will be much lower, but here the number of risk due to lightning will be much higher. So I cannot go for the same design which I did for Rajasthan in the Odisha or West Bengal area. So we have to perform the designing separately. I cannot use the same design for all the areas. So this one recently happened in Mumbai. So in this itself we can find then surrounding buildings. So the surrounding buildings in Mumbai area is much higher. But if you take the Chennai, the building height will be much lower. So based on the city, the surrounding structures and all, the risk also will vary. So in this, the recorded damage was, the physical damage was much lower, but they faced electronic equipment failure. So that will be coming under the indirect effect of lightning strikes. So if you take the damages, we have to consider both direct damage as well as this indirect effects as well. So in this particular site, they faced mainly due to this indirect effects, that is failure of electrical and electronic equipments. So the solution for this kind of failures is proper lightning protection system. So in order to provide protection against both direct effects and indirect effects, we have to go for both external and internal lightning protection system. So the external lightning protection system consists of air termination system, down conductor system and earth system. So this will be acting as a bypass to this lightning strikes. So if lightning is happening, means it will act as a bypass and divert all the energy to the ground without damaging this building. But by providing this external lightning protection system, the electrical equipments inside the building are not protected. So in order to provide protection to this electrical and electronic equipments, we have to go for the surge protection devices. So the surge protection devices will be coming under this internal lightning protection system, and the air termination, down conductor and earth electrodes will be a part of external lightning protection system. So the overall combination of external and internal lightning protection system will be considered as overall lightning protection system. So if we are going for this proper designing of lightning protection system, we have to consider both external and internal. So the number of air terminals required for one site and the spacing between the down conductors, how many down conductors are required, how many earthquakes are required. So the standard has provided a set of detailed calculations and procedures to be followed for this lightning protection system. So for this, we are following the standard 62305. So in the 62305, the second part explains about this risk assessment calculations, and the third part explains about this external lightning protection system design, and fourth part explains about this designing of internal lightning protection system, which is the surge protection devices. So in this presentation, we are mainly concentrating on 62305 part 2, that is external risk assessment calculations for lightning protection system. So based on the risk assessment only, we will be performing the designing of lightning protection system. So the risk assessment provides two outputs. So the first output is whether LPS is required or not. So whether lighting protection is mandatory for all the buildings. So that is the first output, whether this risk assessment will be provided. So yes, whether I have to go for blindly, I have to tell all the buildings should be provided with lighting protection system. So that is not the case. So the first output of this risk assessment calculation is whether I need to go for lighting protection system for all the buildings, or for the particular building, whether lighting protection system is required or not. So the second output is what is the level of protection. So these are the two outputs of the risk assessment calculation. So based on this output only, we will be performing the designing. So without performing the risk assessment, we cannot go for this designing method. So we have to identify the suitable level of protection for this particular site, and based on that only, we have to carry on to this designing of lighting protection system. So the first point is we have to identify the source of the damage, and second one, we have already explained about the sources and damages, and third one is the losses. So if you take the losses due to lightning, the first and foremost loss is the human life. So if any electrical equipment is damaged, means we can replace the electrical equipment, but if our human life is lost, we cannot replace it. So the most valuable thing is human life. So the first loss is loss of human life. Second one is loss of service to the public. So if you take this telecommunication tower or any substation or power transformers and all, if because of the lightning, some of the equipments get damaged, then all the people who are getting service from that particular telecommunication tower won't be getting the service. So that will affect the group of people. So that will be coming under the loss of service to the public. And third one is loss of cultural heritage. So the cultural heritage, if you take India, it is a land of cultures. So we are having so many buildings that were constructed before 1000 years. So we have to protect those structures and all. So those structures explain about this lifetime of the people and lifestyle, cultures, and their advancement in technology, what was their cultures and also these structures carry the details about the lifestyle of those people. So we have to protect them, and we cannot recreate those structures. So they have to be protected properly against this lightning. And fourth one is mainly economic value. So we will be calculating the loss in terms of financial aspects in this fourth loss. So these are the four losses that we will be calculating for this risk assessment calculations. So based on that only, we will determine whether a lighting protection system is required or not. So this is the mapping between the type of loss and the damages. So if you take the source of damage, the first source S1 is lightning directly striking on the structure to be protected. So if the lightning is directly striking on the structure, means definitely it will result in physical damage. Some part of the building will get damaged. So the D2 is related to this physical damage. So the D1 is loss of life, D2 is physical damage, and D3 is equipment failures. So this is the mapping type of loss. So if you take the first loss, L1 is nothing but loss of life, and L4 is economical loss. So if it can cause both L1 and L4 if the lightning is striking on any structure to be protected, and D2 is nothing but the physical damage, and D3 is nothing but electrical and electronic equipment failures. So if you take this electrical and electronic equipment failure, if you take normal house and office building, the risk will be much lower. But if you take an hospital as an example, so if you take an hospital, if a person is on life support, and because of this lightning surges, if one equipment gets failed, then it will result in the loss of human life. So the electrical and electronic equipment failure will also result in loss of human life in case of hospitals and explosive storage areas. So if you take some explosive storage areas, because of the surges, if any equipment fails, which result in a spark, then in that particular case, it will result in explosion. As the result, it will result in loss of human life. So the loss of human life due to this electrical and electronic equipment failure will happen only in terms of hospitals and explosive storage areas. So these are the four losses, four risks defined by the standard. So if you take this, we can group this risk components into four groups. So this RA1, RB1, RC1 are due to the source S1, and RM1 is due to S2, RUVW is due to S3, source 3, and RZ is due to source 4. So in this RA, the particular component RA is due to this injury to human beings, that is D1. So RB is due to D2, RC is due to D3. So RM, so if lightning is striking near the building to be protected, in that case, because of the ground potential rise, the electrical and electronic equipments will get damaged. So this RM1 is due to this D3, that is electrical and electronic equipment failure due to this ground potential rise. And here also the same, D1, D2, D3, and this one is lightning striking near the power line. So lightning striking near the power line will also cause failure of electronic equipments alone. So lightning striking near the power line won't cause this loss of human life or physical damage. So it will result in electrical and electronic equipment failure. So this is the grouping. So in this we can group. So RA, RB, RC. So if you take RA is due to injury to human being. Similarly, in the next group, RU is due to injury to human being. So RA and RU will be of same group. RB is due to physical damage. So RB and RV are same. And RC and RW are same group. In between, RM is also due to this damage D3. And fourth one, RZ. So if you take this RC, RM, RW, RZ are mainly due to this damage D3. So D3 is failure of electrical and electronic equipments. So in this RA and RU are related to this injury to human beings, and RB and RV are physical damage to the structures. So it will be very easy to understand if we split these parameters into different groups. So RA and RU are related to this damage D1, RB and RV are related to the damage D2, and RC, RM, RW, RZ are related to damage D3. So in this you can see, among these components, RC, RM, RW, RZ are applicable for structures with risk of explosion and hospitals, because RC, RM, RW, RZ are the components which are related to the failure of electronic equipments. So the failure of electronic equipments will result in human life because of only in terms of hospitals and explosive storage areas. So in remaining areas, it won't have much effect. So we will be considering this RC, RM, RW, RZ only for hospitals and explosive areas, and we won't consider them for normal buildings. So if I am performing the risk assessment calculation for normal building, then the R1 will be RA plus RB plus RU plus RV, because in normal buildings like residential area and office buildings, there won't be any risk due to this failure of an electronic equipment. So I won't consider this RC, RM, RW, or is it? And for normal buildings, I will be considering only these four parameters. And so the R1 is completed. So if you take R2 is the loss of service to the public. So in service to the public, it will be related to only this physical structured damages and the failure of electronic equipment. So for example, if we take the telecom tower as an example, the electronic circuit boards in this receiver or transmitter may get damaged, or the tower itself may get damaged. So because of that, the public will get affected. So R2 is nowhere related to the loss of human life. So in this R1, if you remove the damages D1, it will be coming under R2. So RA and RU are related to this injury to human being. So in this entire 8 parameters, if I remove RA and RU, it will be coming under R2. R3 is nothing but cultural heritages. So cultural heritages are nothing but the structure, physical structures. So we will be considering only the damages to this physical damages. So D2 alone we will be considering. So if you take the parameter of D2 alone and group it together, it will be coming under R3. So this is how we need to group this physical parameter. So these are the different components of this risk assessment. So if you take R1, R2, R3, R4, these are the 4 risks, and each risk is made up of different components. So we have to group and add the risk components to find the value of R1. So each risk component Rx is made up of 3 different parameters. So Nx, Px and Lx. So these are the 3 different parameters of this component. So if you want to calculate the value of RA, then RA will be ND into PA into LA. So this is the formula for calculating RA. Similarly, there is a different formula for RB, RC, RU like that. So we have to calculate the value of each and every component, and we have to add those components together to find the value of R1. So here the RA is made up of 3 values. So number of dangerous events, probability of a damage, and the consequent loss. So in the number of dangerous events, we will be considering the physical parameters of the structure, environmental parameters, and type of power line, type of data line. So these are the different things we will be considering for the number of dangerous events. And second one is the probability of damage. So in the probability of damage, we will be considering the protection measures that were incorporated to reduce the damages due to lightning. And LX, if lightning strikes, and what will be the consequent loss that will be faced due to this lightning strike. So that is a third consequent loss. So the product of all the 3 components will be the risk component RE. So similar to that, we have to calculate for each and every component, and we have to add those components to find the value of R1. So this is the formula for all the risk components RA, RB, RC, RM, UVW and Z. So based on this formula, we have to calculate those values. So this is the value of the formula for calculating the number of dangerous events ND. So in this, we can observe that the number of dangerous events is depending on NG, AD, CD, CI, CE, CT. So if you take this NG is nothing but ground flash density. So which mainly depends on number of thunderstorm days. So the number of thunderstorm days plays a major role in the number of dangerous events. So in here, the location factor comes into the picture, because for different locations, the number of thunderstorm days will be different. So here we have to consider the location, whether the number of thunderstorm days in that particular area is higher or lower. So that we have to consider. So AD is nothing but this collection area. So for this collection area, we will be considering the dimensions of the building. What will be the length of the building? What will be the height of the building? What will be the width of the building? So here AD, the height of the building plays a crucial role. And CD is the location factor. So if you take this, as I mentioned earlier, if you take one site, for example, if you take the building of 20-meter height, so if you take that building in Chennai city, so that will be the average height of all the buildings here. But if you take the same building in the center of Mumbai, then this is nothing, because all the buildings will be of 20 floors and 30 floors. This building will be nothing among them. So based on that location, it will be different. For example, whether the building is located inside the city or building is located outside the city, building is surrounded by the structures of the same height, or building is surrounded by structures of higher than this building, or the building is located on the hilltop. So if the same building is located on the hilltop, the risk will be much higher. So these are the parameters which will be considered for calculating ND. So if you take this transmission line, power line and data line, so here we will be considering CI, CG, CT, which is related to the type of line and installation parameters. I will explain in the upcoming slide. So here, if you observe, means all these parameters are constant. Even though if you incorporate any protection measures, I cannot alter the building height or building dimensions and all. I cannot alter the number of thunderstorm days. So the values which we are observing from this calculation will be a constant. So there won't be any change in the value. So it will be fixed for one side. So this is the collection area. So if you can observe this formula, it is mainly depending on the height. So 3 into height and 3 into height is the whole square. So based on the height, the collection area will be different, increasing. So if the height increases, collection area will be increasing, which as a result, ND will be increasing. So this is the structure location factor which I explained, CD. So if the structure is surrounded by higher objects, then CD will be 0.25. So if the structure is located on the hilltop, then the value is 2, which will be much higher. So if we are multiplying it, we are not adding. So we are performing the multiplication. So the result will be much higher. So if it is structure is surrounded by higher objects, it will be nothing but 1 by 4. But here we are multiplying by 2. So that is the difference of location. Line insulation factors. So CIKIT we consider for this transmission line and data line. So aerial and burial. So if the transmission we are going for aerial, that is overhead power lines, then the probability of lightning directly striking on this line will be higher. So the value of aerial line will be higher, and if I am going for buried, the direct effect will be lower, but there will be some effect due to the induction. So to avoid those induction effect, we are the load we are going for the lower value 0.5. So in aerial line, the risk due to direct lightning strike is higher, so we consider the parameters 1. In buried line, we are considering only the indirect effect, so the value will be 0.5. So line type factor. So if you are going for low voltage line, the risk will be higher. If it is high voltage line, 0.2. And environmental parameters. So if the environmental parameters are related to this rural and urban areas. So if it is a rural area, it will be 1, and if it is an urban area with tall buildings, it will be 0.0. So it depends upon the location and the surrounding structures. So these are the environmental parameters. So the next part is the probability of damage. So in the second part, probability, we will be considering the protection measures incorporated. So here we can observe this protection measure. So if there is no protection measure, the value of PTA is 1. If we are providing warning notices, so here the main thing they have mentioned about is the step and touch potential. So if the distance between the human being and the particular conductor is higher, the effect of step and touch potential will be much lower. So in order to inform that there is a chance of hazard due to the step and touch potential, we have to provide warning notices. So if we are providing the warning notice, then the risk is lower. So if I am providing this electrical installation, like providing a barricade or providing some PVC pipes surrounding the conductor so that we can avoid this direct contact. So by providing that kind of structures, we are reducing the risk further. So these are the protection measures. So if I am taking the protection measures, then I am reducing the probability of damage. So the probability always explains about the protection measures which we take for reducing the damages that can be caused due to this lightning. So this one is PB. So this one is depends on the class of LPS. So for example, if you take one building, so if I have already installed lightning protection system and still the risk is high, then I have to go for this higher level of protection. So in this we can find that for different level of protection there is a different probability of damage. So if I am going for higher level, then the probability of damage is much lower. So in this we can observe that. So for level 4 protection it is 0.2, but if I am going for level 1 protection it is 0.02. So this mainly depends upon the level of protection which we have incorporated for the particular building. So if I am performing the risk assessment calculation, if the risk value is higher, then I have to incorporate the protection measures. Then after incorporating this particular protection measure, what will be the actual risk? So what will be the reduction of risk after incorporating this protection measure? So we can calculate by substituting this updated value. So for example, during this first calculation, if I am taking level 4 protection and I will consider 0.2 as the parameter. So if the value is higher, then while proceeding the calculation, I will be updating the calculation with level 3. So in that case, I will repeat the same calculation with the updated value of 0.1. So still, if the value is higher, then I have to go for level 2. So while going for this level 2, I will be considering the value 0.05. So in this probability of damage only, the values are getting updated. But if you take the number of dangerous events, so all the values will be fixed, we won't consider the values. So in this probability portion will be all the calculation will be updated based on the protection measures which we are incorporating. So this is due to the physical damage. Similarly, if we are going for this power line protection, so for power line protection also, if we are providing surge protection devices, what will be the risk provided? So if there is no SPD, then the value of PEB will be 1. If I am providing level 3 or level 4, the PEB value will be 0.05. So by incorporating this protection measures, the value of risk can be reduced. This is the third portion, loss. So in this loss, we can observe that there are different parameters involved in it. So LT, RT, LT, NZ, NT, TZ. So we have provided the explanation for this. So in this, the RT is dependent on the type of soil and floor, because it may depend. We are considering this value because of this ground potential rise. So the soil resistivity and the type of flooring will aid in this ground potential rise. So if I am having a very highly insulating material as a flooring material, then the ground potential rise can be much reduced. So if you take the substation as an example, they are putting a layer of gravels on the surface because they have to increase the surface resistivity so that the ground potential rise won't affect the people standing on the surface. So if I am providing a surface that is a ground flooring with a highly resistive material, then the effect will be much lower. So the RT depends on the type of soil and the flooring materials you are using. And RP is the consequences of fire. So here, what is the protection measure which I take to reduce the damage due to the fire? I can install either manual firefighting system, or either I can go for this automatic fire extinguishers. So that is the factor which I am considering here. So if I have installed this automatic fire extinguisher, then the loss will be much reduced because it will operate without any human interruption. So there won't be any delays. So if I am going for this automatic fire extinguisher, the risk will be lower. So this RF factor, it will be related to the risk of explosion. So the risk of fire and explosion is very specific to certain structures where we are handling this chemicals and explosives or inflammable materials. So for those kind of structures, we will be considering the risk of fire and explosion. HZ is the very special hazard in this particular area. So if I'm taking any chemical handling plant, whether they are having any explosive materials, so in that particular area, what will be the risk? So for that particular area, is there any special hazard? For example, if we take some events like a sports events, stadiums and all, in those kind of areas, the evacuation will be the most difficult thing. So in that particular area, that evacuation will be the special hazard. And N is the number of persons. So the number of persons in that particular site also will be considered for this losses. And NZ is the number of persons on the particular zone, and NT is the total number of persons. And TZ is the time period of the person, availability of the person. For example, if you take some manufacturing industries, they will be operating 24/7. But if you take some other industries, they might be operating only 8 hours in a day. So if the lightning is striking on at the mid time, that is midnight time, so if it is a 24/7 operating factory, the loss will be higher. If it is a normal factory and the lightning is striking at the midnight, there won't be any person who will be working on the particular site. So in those particular sites, the risk will be lower. So he will be considering that time in hours per year for also as a parameter. So these are the different parameters that we'll be considering for the loss. So we have explained about the 3 parameters. First one is the number of dangerous events. Second one is the probability, and third one is the consequent loss. So the product of all these 3 products will be giving the component, risk component, RA, RB, RC, like that. So similarly, we have to find all the risk components, and the summation of all these risk components will be the corresponding risk R1, R2, R3 and R4. And how can we tell that whether the building is safe against lightning or not? So the standard has provided a value called the tolerable risk, RT. So RT is the limit the standard has provided. So if the risk which we are calculating is less than this RT, so if the R value, for example, I am taking R1 is less than RT, which means that the risk due to lightning in that particular area is low. We can consider that protection building is protected against lightning. So if I am performing the calculation and I found that the value of R1 is greater than RT, then what I have to do is I have to incorporate this protection measures. So for example, if I have considered the building without lightning protection system and I found that R1 is greater than RT, then I have to incorporate the protection measures, like I have to install lightning protection system. I can go for this notice, warning notice, or physical isolation, like kind of things. I also installed surge protection devices. So by doing this kind of activities, I can bring down this risk value. So the ultimate aim is the R1 value has to be reduced less than this RT. So if the value of R1 becomes less than RT, then we can tell that the risk due to lightning in that particular location is low and the structure can be protected as considered as protected. So this is the procedure for performing the risk assessment calculation. So the first thing is we have to identify the site. So we have to analyze the site and we have to identify the risk component, because as I mentioned, RC, RM, RW and RZ. So these components are applicable only to this structure with risk of fire and explosion, that is failure of electronic equipment that will result in human life. So we will consider these four parameters only for hospitals and areas where it has explosion risk. So for the remaining sites, we won't consider this RC, RM or RZ. So the first thing is we have to identify the component of or components that will be applicable for that particular site. So after that, we have to perform calculations for identifying the values of each components. And third one, we have to add all those four components. For example, if we take normal building, we have to add RA, RB, RU and RV. So this is for normal buildings. So if I add all these values, I will be getting the value of R1. So after that, I have to compare R1 and RT. So in this case, if R1 is lesser than RT, then the risk due to lightning is much lower and we can consider that building as protected. So if you take some site as example, and if the value of R1 is less than RT, even without this protection measures, like even without installing lightning protection system, if the R1 is less than RT, then there is no need for additional protection system. So which means that the risk due to lightning on that particular building without this lightning protection system is much lower. So which doesn't mean that the lightning won't strike on this particular building. So which means that the risk due to lightning is lower. Even though if lightning strikes on that particular building, the risk and the losses will be much lower on that particular building. So it is up to the customer to go for this level of lightning protection. So whether we need to go for this level 4 or not. So but R1 value less than RT doesn't mean that lightning won't strike on the building. Even though if the lightning strikes, the risk due to the lightning will be much lower on that particular building. So we have to perform the calculation, still this R1 becomes less than RT. For example, if we take R1 is higher than RT, then I have to incorporate the protection measures and I have to repeat those steps till R1 becomes less than RT. So I will start with level 4 of protection, then I will move to level 3, then I will go to level 2, and after that finally I will go for level 1 protection. So the ultimate aim is we have to reduce the value of R1 so that it will be lesser than RT. So this is the flowchart provided by the standard. So first one is we have to identify the structure to be protected. So we have to collect all the records. So in this calculation we have considered so many parameters. So the calculation involved so many parameters. So we have to identify the values of each and every parameters, and after that, based on the values collected, we have to find the value of RA, RB, RC, RM, UV, W, and Z. So the summation of all these components will be giving the corresponding risk R1, R2, R3. So we have to compare those values with RT. So if the value of R1 or R2 is lesser than RT in the first stage of itself, then we can consider that the structure is protected and the risk due to lightning is lower on the particular site, and we can finish the calculation there itself. But if the R1 value is greater than RT, then we have to go for this protection measures. So the protection measures are providing lightning protection system or providing surge protection system or providing additional protection measures against this firefighting system like that. So we have to incorporate this required protection measures, and we have to bring down the value of R less than RP. So if we take this RA, RB, RC, if we observe the particular value, we can come to a conclusion that what will be the factor which will be resulting in the higher value. So for example, if the RA value is higher, we have to mainly focus on the parameters that will result in the involved in this RA, and we have to incorporate the suitable protection measures. Because if you take the RA, the power line parameters won't be considered. But if you take RU, the power line parameters will be considered. So if you take the risk value is higher in RU, then we have to consider the protection measures that are related to the power line and the data line. So by incorporating the protection measures related to this power line and data line, we can reduce the value of RU, thereby reducing the value of R1. So we have to repeat this cycle till the value of R becomes less than RP. So that is the ultimate aim. So these are some of the inputs that are required for performing the risk assessment calculations. So the first one is the layout of the building, because as we mentioned earlier, so ND is the number of dangerous events is one of the important parameters in RX. So the formula is RX is equal to NX into PX into LX. So here the ND depends on the location. So what is the location of that area? What is the length, width and height and the surrounding parameters? So for that we need to get the overall layout, elevation and the terrace of the building. So these are related to the dimensions of the building. And fourth one, details of the existing lighting protection system. For calculating the probability, we will be considering different values like PB and all. So for PB, we have seen that the value is different for level 4 protection, value is different for level 3 protection, level 2 protection. So if they have already installed lighting protection system, then we have to collect the details like what is the level of protection they have already installed, because for determining the value of PB and all, we need those values. Details of the existing earthing, so whether they have provided sufficient earthing or not, because in lighting protection system we are bypassing this energy into the ground. So the ultimate is we are dissipating the energy into the ground. So the earthing plays a major part in this lighting protection system. And focus of this individual buildings, because I will explain, we have explained about this hazardous area and risk of fire and explosion. So if you take a huge factory, the risk of fire and explosion won't be there in all the buildings. In particular areas where we will be storing this explosive in petrol or that is fuels or any chemicals, in that particular area will be risk of explosion and fire will be higher. So for that only we are asking about what is the purpose of the building. So if it is a residential building, the risk will be much lower. But if it is a manufacturing plant where they are handling chemicals and all, the risk will be higher. And this number of people, this is an important parameter in determining the loss, third component. So for that only we are getting the number of people. So how many people will be there and what will be the duration? Whether the people will be staying 24 hours a day, that is a factory MNC which will be operating 24/7, or if it is a normal building where people will be working only for 8 hours a day. This Google Map coordinates or the location. So here, based on this, we can get two outputs. One is number of thunderstorm days in a year, and second one is the surrounding buildings. So whether the building is located in inside the city, or whether the building is located on a rural area or urban area, or whether inside the city or it is in a hilltop. So these details we can get from the Google Map coordinates. And nature of soil and soil resistivity, this we are considering because of this ground potential. So the ground potential, the soil resistivity plays a huge role. So this type of floor also it is an important parameter in the loss. So further on we are getting those details. And if you take the power line, so as I explained, so the CIKIT, this three values varies based on power line parameters. So if it is an aerial, so the direct effects, that is the probability of lightning directly striking on this power line will be much higher. So the risk due to lightning will be higher if it is aerial. But if you are going for underground, the effect will be only due to the induction. There won't be any direct effects. So if you are going for underground cable, the risk will be much lower. And whether the cable is armored or unarmored, if it is the shielded cable, whether they have connected the shielded shielding to the ground properly or not. So that also plays a huge role in reducing the risk due to the damage. So if you take the data line, so what is that type of data line they are using? So if you take the data line, commonly we will be using Cat5 or Cat6 cables. But nowadays, these optical fiber cables, OFC, are coming to the picture. So if you take this OFC is nothing but optical fiber. Here the data will be transferred in the form of light. So here there won't be any conductive parts like copper cable won't be there, copper core won't be there in OFC. So we are providing protection to this power line and data line to protect those electrical and equipment from the surges. In the data line, if it is a OFC cable, the chances of surges will be much lower. So there is no need for providing surge protection devices for this OFC cable because it does not contain any metallic conductive parts. So the conduction will be taking in the form of light only. So we won't be providing this surge protection devices for this OFC. So we need to understand what type of cable they are using and what type of conductors they are provided. So based on that only we can provide suitable surge protection devices. So here whether they have provided surge protection devices or not. So here we can see about probability of damage PEB value. So the PEB mainly depends on the surge protection device they have installed, and there is one more parameter called the PSPD. So for that parameters we are getting the details of the existing surge protection device. Fire protection system. So we have already explained about these terms while explaining about the loss. If they have already installed this manual fire extinguishers, the risk will be little higher because it may take some time for those people to operate the extinguisher. So if they are going for this automatic sprinkler system, then there won't be any human interruption. So it will operate automatically. So the risk will be much lower if we are going for this automatic sprinkler. So for that particular loss component, we are getting for this details of the extinguishers they have provided. And risk of fire and explosion. So the risk of fire and explosion won't be there for all the buildings. If for the particular site condition, if there is any special hazard, if there is a component which is highly inflammable, then we are getting the corresponding details for calculating the loss component of this risk component. So this all the 322, 23, 24 will be related to the loss component. So LX. So these are the details which we need to collect from the customers for performing the risk assessment calculations. So based on this input, we have to select the corresponding values of the different factors. So standard, we have seen in the tables like standard has already provided different tables for CD, CI, CE, CT, PEB, PSPD, loss components and all. So from the table, based on this input, we will get the input. So if it considers the overall parameters, it will be more than 60 parameters are involved in this calculation. So based on this output, we will be calculating the corresponding risk. So the ultimate aim is we have to bring down the risk value less than the tolerable risk provided by the standard. So for performing that, we need this kind of inputs. So conclusion. So I have posted 3 questions. The first question is whether I need to go for this lightning protection system for all the buildings. So the lightning protection system is not mandatory for all the buildings. So we have to perform the risk assessment calculation. If the risk value R value is less than RT, if the R value is less than RT without this lightning protection system, then the risk due to lightning on that particular site is much lower. So in that particular case, it is up to the customer to decide whether they need to go for the lightning protection system or not. So lighting protection system LPS is not mandatory for all the buildings. So based on the risk assessment only, we have to determine whether lighting protection system is required for the particular building or not. So second one, how can I select the level of protection? So first one, I have to calculate the R1 value without LPS. So if the R value without LPS is greater, that is R1 is greater than RT, then again I have to calculate R1 with level 4. LPS is LPL level 4. So level 4 protection, then I have to compare with R1 and RT. So if R1 is greater than RT, then I have to go for LPL with level 3. Then if in that case also if the value is greater than RT, then I have to go for level 2 and level 3. So based on this, I have to repeat the loop till the R1 value becomes less than RT. So I cannot generally tell that the level of protection for a building. For example, if you take one building in Chennai, the building height will be 20 meters. So if you take the building in Chennai, that will be their normal building. So the risk due to lightning will be little lower. But if you take the same building in agricultural land in Odisha or Bhubaneswar area where the number of lightning strikes is much higher. So in that particular area, number of lightning strikes is also higher, and the 20-meter high building will be the tallest structure in that particular area. So in that case, the risk due to lightning will be much higher because the location itself is receiving more number of lightning strikes and the structure is the tallest structure in that particular area. At the same time, if you take the same structure in Mumbai area, 20-meter height is nothing in the Mumbai area. So all the structures surrounded by those buildings will be much higher in height. So the risk due to lightning on that particular area will be much lower than Chennai itself. So we cannot go for this general solution for all the site conditions. Even though if you take the same building of same dimensions with same applications, for example, if you take one building, the application is only a residential building. So if you are having the same building in Chennai, you are having the same building in Odisha and same building in Mumbai. If you calculate the risk component, definitely the risk value will be different because the risk value for all the three sites won't be equal. So we cannot go for this generalized calculation for the one building and we cannot apply it for all the buildings and all. So for each and every building, we have to calculate this risk component separately and we have to go for this customized solution rather than the generalized solution. So it is not recommended to go for this generalized solution like it is for residential building, we have to always go for level 4. That we should not do. We have to perform the risk assessment calculation and based on the output of the risk assessment calculation, we have to select the suitable level of protection. And third point is, if the same building is located on different areas, whether it is applicable, the same level is applicable, it is not applicable because the environmental parameters and a number of lighting structures, so that comes into the picture. So it may come, but we cannot directly tell that the lighting protection will be same for all the buildings of same different locations. So it won't happen. We have to perform the risk assessment separately for separate structures. Thank you. So we have covered this basic of this risk assessment calculation. So if you go through the standards or any reports, then now we can easily understand what are the different parameters involved and why they have considered these parameters involved. So it is a basic idea. We have explained about this basic parameters involved in the calculation of risk assessment system. So we hope it will be understandable to you.